For section 2.2, we have it on histogram, frequency polygons, and ogives. So in 2.1, we already learned how to organize the data into a frequency distribution. In this lesson, we're going to use the frequency distribution to draw the graphs. And the three graphs we focus on this lesson are histogram, frequency polygon, and ogive. So let's take a look at what we have in a histogram. A histogram is a graph that uses bars to represent the frequencies of the classes in a frequency distribution. So meaning that when we think of a histogram, we think of a bar graph, and the height of the bars would be the value of the frequencies. The second graph we're going to look at in our lesson here would be frequency polygon. Now, frequency polygon is a line graph that connects the frequency of each class at the midpoints. So we would need the midpoints, which we learned how to compute the midpoints in section 2.1 already. And the third graph we're going to look at on this lesson would be an ogive. For ogive, we use the cumulative frequency, all right? And I'll show you how to build the cumulative frequency in a minute. So example 1, construct a histogram, frequency polygon, and ogive for the following data. Comment on the shape of the histogram. So you're fairly familiar with a frequency distribution. That's the reason why in 2.1, I started off with raw data to have you build a frequency distribution. All right, so now given what we have here, given the class limits, the frequencies, and we know that what we have for the class limit here in terms of whole number, because what? It goes from 1 to 5, then the next one is 6 to 10, next one is 11 to 15. That's how we can tell we have whole number. So then we need to create a column for class boundaries. As you already know, for whole number data, class boundaries we're going to do by minus 0.5 and plus 0.5 with the class limits. So since we worked on 2.1 in detail with class boundaries, I'm going to just project the class boundaries here, all right? Then the frequency column that's given from the problem, I have it here. So what we're going to do, we're ready to draw a histogram. Let me explain to you how to draw a histogram on paper first, and then once I finish with this whole problem, then I will show you how to actually do the graph on Alex. All right, so on the horizontal axis, you're going to have all the class boundaries. So from 0.5 to 5.5, that's our first class boundary. Our next class boundary is from 5.5 to 10.5. Since 5.5 is already labeled already, we just need to write 10.5. Next one is 10.5 to 15.5. 10.5 already labeled. We just need to label 15.5 next and continue to label for the rest of the class boundaries. Now, the good thing about it when you do the graph on Alex, the grid is already prepared for you. It's already labeled for you. So on the horizontal axis, we have the class boundaries. On the vertical axis, we have the frequency. Here we see that from our data, the lowest frequency is 0 and the highest frequency of 25. So it's really up to us, just like how we graph it on an XY plane, which is a Cartesian plane. We'll pick a scale that's convenient for the data. So here, I pick a scale of 5 that's convenient for the data. All right, so now we said that a histogram is a graph that uses bars to represent the frequencies of the classes in a frequency distribution. So what we see here, from 0.5 to 5.5, we have the frequency of 21. So we just do our bar up to 21. Next, from 5.5 to 10.5, we have the frequency of 25. Next, we have from 10.5 to 15.5, we have the frequency of 15. 15.5 to 20.5, we have the frequency of 0. 20.5 to 25.5, we have the frequency of 8. And the last one, 25.5 to 30.5, we have the frequency of 6. So based on the values of the frequency, we're going to go up to that number for our bar. Now, when you do the graph on Alex, Alex says you can drag the bar to move to the number that you wanted to graph on the frequency. My advice for you is when you do the graphing on Alex, you key in the number. So for example, if the frequency is 21, you key in 21, then the system will plot it for you. Press enter, then you will get a plot. All right. And like I said, I will show you how to do it on Alex once I'm done with this example. Next, we're going to do a frequency polygon. So now, for frequency polygon, we would need the midpoints, which you know how to compute the midpoints by taking the lower class limit, add it with the upper class limit, dividing it by 2, okay? Then we also need the frequency column. All right, on the horizontal axis, you're going to have all the midpoints. So you see here that the first midpoint we have is 3. The second we have is 8, third we have is 13. So these number here on Alex, you will see them labeled the midpoint for you. You don't have, the good thing about it is that you don't have to do the computation for the midpoints because the grid is labeled. That means the midpoint is already done. Now the frequency, I'm going to use it by 5 as well. So here's in algebra. So in algebra, when you graph it on a Cartesian plane, you graph it as x comma y. So now our x-axis is being replaced by the midpoint. So here in a frequency polygon, instead of the x-axis, you're going to have the midpoint, comma, the y-axis would be the frequency. So now, on our very first point, we have the midpoint of 3, comma, 21. So this point right here, what I have is 3, comma, 21. Next is 8, comma, 25. What do we do with these points? We connect the dots, okay? We have 13, comma, 15. We have 18, comma, 0. 23, comma, 8, and 28, comma, 6. Now, for the frequency polygon, you always start it on the horizontal axis. That's what I have this line for. The very first line that go up to the first dot, and the very last line that dropped it back down. The reason why is that the name of the graph is a polygon. Polygon is a line figure that is a figure made up of line segments, and it has to be closed. So that's why we have this. So pay a close attention that you started off your first point, then it's going to start from the horizontal axis, which is the midpoint axis here, to go up to the first point, okay? That's why it started at 0 here. All right, now for an Ogive, you need the cumulative frequency. So let me go back to the original data so that I can show you the frequency first. How to build the cumulative frequency. So first of all, what does it mean? If I tell you your final exam is a cumulative final exam, meaning that you're going to be tested everything from day 1 to the last day, right? So likewise, for cumulative frequency, the first cumulative frequency is the same as the frequency. That's all we have accumulated so far. The second cumulative frequency, we take the first, add it with the second, here we get 46. The third cumulative frequency, you add all 3 frequencies. So since the first 2, we get 46 already. Then we take 46, add 15, which we get 61. Next one here, 61 added with 0, which we get 61. 61 added with 8, 61 added with 8, 69. 69 added with 6, which equals to 75. Now, without seeing a raw data, because the cumulative frequency, that's up to 75 data values, that tells us the data set has 75 data values, okay? That's just information. But as far as to do an Ogive, it's a graph that represents a cumulative frequency distribution. So now that you have cumulative frequencies here, okay? Now, on Alex, you will see that it will break it down for you like this. It will ask you for the first class boundaries in our problem. is from 0.5 to 5.5, right? So first class boundary from 0.5 to 5.5 with the frequency of 21. It will ask you on the very first one that less than 0.5, and this one is always 0. The reason why it's always 0 is that so that the graph can start on the horizontal axis. Now next we have less than 5.5, which we have, this is your 21 here. This is your cumulative frequency of 21, 46, 60, no, 46, 61, 69, wait, am I missing something? 61, 61 again, sorry. 61, 61, 69, and 75. All right. So to draw an ogive on the horizontal axis, you have the class boundaries. The vertical axis, you have the cumulative frequency instead of the frequency. So the first one, you go from the cumulative frequency of starting at 0, go up to 21. After the next cumulative frequency is 46. After that, the next cumulative frequency is 61. The next cumulative frequency is 61. The next cumulative frequency is 69. And the last cumulative frequency of 75. All right, so that's how you do the 3 graphs for this lesson. Histogram, frequency polygon, and Ogives. Okay, now what I have here, the second example, very much the same thing, but what we have here, we're still working on histogram, frequency, polygon, and ogive. The only thing we have changed here is our data. Instead of whole number from example 1, we now change the data to 1 decimal place data. And in terms of 1 decimal place data, you already know how to do the class boundaries. From our previous lesson, we know that 1 decimal place data, our class boundaries, we're going to do by 0.05. All right, and here is what we have for histogram. Here's what we have for frequency polygon, and notice it's closed. And the last one we have is an ogive. And so we use the cumulative frequency. Now, going back to what is asking us here to comment on the shape of the histogram. All right, so the easiest way to comment on the shape of the histogram is to take the total frequency of 75. If you take 75, you're dividing it by 2, so you see where's the halfway mark, okay? So we take 75 divided by 2, we get 37.5. So then now, when you look at your histogram here, the very first bar you have is 21. The second bar you have is 25. So now, if I add the frequency of 21 and 25, that's 46, that's more than this already. So meaning that the 37 data value would be somewhere in this bar here, right? So then what we compare, we see that a lot more going on the right-hand side, a lot more graphs, bars on the right-hand side compared to the left-hand side. So meaning that we're going to have a right skew, okay? Or skew right, another, so skew right. When you have more bars on the right-hand side, you have right skew or skew right. When you have more bars on the left-hand side, you have left skew or skew left. And how can you tell where to mark your line here? You take the total number of data values, you divide it by 2, and you look at to see what bar contains the number of data values here, okay? If you have about the same on both sides, then the graph would be symmetric. So now, let's take a look at what I have in this this histogram for the second example. So I wanted to focus on comment on the shape of the histogram. All right, so when we add up all the frequencies, okay, so when we add up all the frequencies, we have, let me share my calculator, 10, sorry for the lighting, 12, 6, 8, 4, and 2. here we have a total of 42. So our n value equal to 42. You take 42 divided by 2, which you get 21. So now, if you look at what we have here, the first bar we go up to 10, the second bar we go up to 12. So meaning that is about right here, 21, 23, the 21st, 22nd value when you look at the arranged data, right? Now, I do see that we also have more bars on the right-hand side compared to the left-hand side. And again, this is an example of a positively skewed, or another word is right skew. So I focus on giving you example of positively skewed because you have more bars on the right-hand side. But when you have more bars on the left-hand side, then that would be negatively skewed. Okay, then what I have here for this, I'm going to quickly go over this type of problem. Remember, we spend a good amount of time in section 2.1. So when we have raw data, so definitely when you do your homework assignment for 2.2, you will see raw data problem like this. Go back to section 2.1 in the guided notes that we went over like really details, all right? So what this question is asking us here, the number of counties, divisions, or parishes for each of the 50 states is given below. So we have raw data. This problem is giving us raw data. We need to, first of all, construct a group frequency distribution using 6 classes. So we divide it up into 6 subgroups, all right? Once we have the table, then it's just like example 1 and example 2, then what do? We draw a histogram, a frequency polygon, and an ogive. Analyze the distribution, comment on the shape of the histogram. So just like what we did with example 1 and 2, so I don't need to go over details on this one here. Now, in the next one, what I wanted to mention is that I already did the solution for you, but I wanted to quickly go over that the question is asking for construct a cumulative relative frequency. Okay, so we're not doing cumulative frequency, but what we're doing here, we are doing cumulative relative frequency. So given the class boundaries and the frequency, and what it's asking for cumulative relative frequency, first of all, you compute the relative frequency. After that, you keep adding the relative frequency that will give you the cumulative frequency, a relative frequency. Just like how when you have the frequency, you can find the cumulative frequency. Here you have the relative frequency, you can find the cumulative relative frequency, okay? And then you just do the graph, that's where straight forward. All right, so now what I'm going to do, I'm going to share my computer screen to show you how you can do your graph for section 2.2 on Alex. So bear with me here. Let me open up Alex and then I'll switch my sharing screen over so you can see how we actually can do a histogram. We can do a frequency polygon and an ogive on Alex. Okay, so let me project section 2.2 homework assignment. All right, I have the screen open up. Let me do a new share here. Okay, so this is your first question in section 2.2. What we're given here, the number of bears killed in 2010 for 52 counties in Pennsylvania is shown in the frequency distribution. So we have the class limits given along with the frequency. And we also have the total frequency is 52. Now, part A, what we have here, we're asked to draw the histogram. All right, so what we have, class limits go from 1 to 25, frequency of 18, 26 to 50, frequency of 12. And I'm gonna bring it down for you to see here. On the horizontal axis, you already have the class boundaries done for you. So given the class given the class limit from 1 to 25, meaning that we have whole number data. Our class boundaries, we're doing it by 0.5, which we should have class boundaries for the first one from 0.5 to 5.5. And we're going to graph it up to 18. And what it's telling us here, drag the bar to change the value. My advice for you is that what you do, you click on here, 0.5 to 25.5, key in the number 18, press enter. All right, then the system will plot the very first bar for us. So now, to save time, what I'm going to do, I'm going to take a picture of what we have for our data here, and our next frequency would be 12. So what you do is you key in the number 12, press enter, or even without press enter, when you move it over to the third one that you need to key in the frequency, the system will plot it for you. I'm going to key in 7. I'm going to key in 6. I'm going to key in 2. I'm going to key in 3. I'm going to key in 0, which is that's it. I'm going to key in 2. I'm going 0, 2. All right, and press enter. So this is what we have for our histogram. All right. So now let's check on this and see how we're doing. The green check off, meaning that we did it right. Okay. Now looking at this one here, again, the total frequency we have is 52. Think about it. N equals to 52, we divide it by 2, we get 26. So we get 26. If we draw a vertical line, here we have 18 and 12, that makes it 30. So 86 is 26 is about right here, right? We see much more bars on the right-hand side compared to the left-hand side. So if I ask you to comment on the distribution, this would be right skew or positively skewed. Okay. Now, this one is just a critical thinking question. How many counties had 150 or fewer bears were killed? Then you just look at 150 or fewer. So you take all the frequency from 18, 12, 7, 6, 2, and 3 is the last one because the class limits go up to 150 here, that you have the frequency of 3. Okay, so that's how you do your graph for histogram on Alex. I'm going to move over to show you how you do a frequency polygon. All right, so for frequency polygon, we need the midpoints. But like I said, the nice thing about that, the grid is already created for us. So these numbers here, 13, 38, 63, and so on, these are the midpoints. And let's see if that's true. Our first class limit from 1 to 25. To find the midpoints, we add 1 with 25, we get 26. 26 divided by 2, we get 13. Okay, so that's where we get our first midpoint here. Now, remember, a frequency polygon start at 0. Okay, so let me copy. Let me take a picture of this data and let me show you how to do it. Then the vertical axis you have is the frequency axis. So you keep the first point at 0. The second point here, you're going to key into how high your frequency goes. It goes to 15. And you key in the number 15, press enter. Then you will have the first line segment connect from 0 up to the frequency of 15. Then you will see that. Let me press enter. There we go. Then the next one over, you're going to key in 12. Why are we keying 12? Because after 15, we have 12, 7, 4, 3, 2, and so on. Okay. Then you key in here, you'll have 12, you have 7, you have 4, you have 3, you have 2, you have 0, you have 3, you have 0, you have 3, and remember, the last one on a frequency polygon, it has to be 0. So remember, the first one is 0 and the last one is 0. So that way we have a figure made up of line segment and it's closed. That is a frequency polygon. So I'm going to go ahead and check it here for you. And the green check off is correct. And as you know by now, I have all these resources available on the right-hand side for you. You have the explanation. When you click on the explanation, it tells you to lose the current attempt, but you don't lose the point. After you view the explanation, you can try another problem and you still can get the point for that question. You have the guided solution, it guides you to answer the question. You have the example, give you a similar problem to what you work on. The ebook, it takes you to section that you're working on, and the envelope, the message center, you after all these resources, and if you still need help, you're welcome to send me a message and it will send it over to my end. And the good thing is that you don't have to tell me what's the problem. The problem, it will attach the problem for you. You just need to tell me what you need help with, then I will come in to provide feedback for you. All right, so that's the second graph on frequency polygon. And the last graph would be on an ogive. But before we get to an ogive, it's asking us to construct a cumulative frequency distribution. So what you notice here, our class limit from 0.5 to 25.5 with the frequency of 16. So it's less than 0.5. And like I highlighted for you, the very first one is 0. Next, we have 16, and 16 plus 10, we have 26. 26 plus 8, which we have 34. 34 added with 5, which we have is 39. 39 added with 1, we have 40. 40 added with 3, we have 43. 43, and after 43, we have at 0, which we get 43 again. We add 3, we get 46. Add 0 again, we get 46. And the last one we have at 4, which we get 50. And you notice that we have this number here on the last one, 50. It does tie it to what we have for the total. So that's how you know you're doing it correctly. And I'm going to go ahead and check this. And that green check off, and this green check off here, that means we did it right. Now, once we have this, we're ready to construct an ogive. Ogive on the horizontal axis, you're coming back to class boundaries, like how you did it for a histogram. Frequency polygon is the only one that we have. Frequency polygon is the only one that we have on the horizontal axis or the midpoints. But histogram and ogive, we use the class boundaries. Okay, so now for ogive, you leave the very first one start at 0 as well. Okay, and you're going to, what I'm going to do to make it easier for me and myself here, I'm going to take a picture of the data. Now, instead of drag the bar, I'm going to key in 16. So you see right here, the values we have for our cumulative frequencies are 0, 16, 26, 34, 39. Okay, so I'm going to key in. And as soon as I key in, move it over to the next number, the system will plot it for me. So after I key in number 26, I'm going to use my mouse, move it over to the next one of 34, and the line segment is graph for me. 39, I have 40, I have 43, I have 46, I have 46. Oh, wait, hold on, let me double check. 0, 16, 26, 34, 39, 40, 43. I have 2 times 43. 43. And if you change the value, it will change in the system for you. You don't have to regraph it over. 46, and the last one is 50. Now for an ogive, because we use the cumulative frequency, it starts at 0, but it doesn't close at 0. It doesn't drop down like a frequency polygon. Okay, and that's it. That's what we have for ogive for the graph, and we do get it a green check off. That's pretty much what we have for the rest of your homework assignment for 2.2 in terms of working on these three graphs. And you see here, this problem is what I would recommend you to do is to look at the example that I did it in section 2.2 as a review problem. But going back to section 2.1, you will see more details, okay? And after this, after you build the frequency distribution table, then what you're going to do, you're going to do the three graphs. That's why it has 6 parts here, okay? Question number 5, you're doing the frequency polygon. Question number 6, you are doing it for the Ogive. And question number 7, you have another problem in terms of raw data like this. And that's what I have covered for you for section 2.2. I hope you find this helpful, and I will continue to do more recorded lecture videos for you to follow along with your guided notes. So thank you for watching.